Okay, so once you have a Lie group, then we can start talking about actions of Lie groups and manifolds. Okay. So a left action, there are also, of course, right actions. So left action of a Lie group, G, right, on a manifold M. Is a smooth map let's call that lambda. It's a map from G cross the manifold to the manifold, which satisfies the following property. Okay, the first thing is that the identity fixes a point in the manifold, as you might expect. Okay, so the action of the identity element on any point y on the manifold is just y itself, right? So this is true for all y in the manifold. Okay, so another way to sort of think about this is that the identity element acting on something is just the identity on map on the manifold in some sense. Okay, so that's sort of another way to think about this. Okay, and then the other one is that there's a sense as to what happens when you apply it's like the left action twice, and with two different it's like group elements, and how you can think of that action as being the action of a product of the group elements. Okay, so if you take the sort of a group element P acting on the action of R on a point Y, right? So you first apply R, you first have R act on Y, then you have P act on whatever this is. Okay, so you should be able to write this as the action of something on Y. And what you would like it to be is that it has to do with the composition of P and R, but in the group. Okay, so this is P dot R. Okay, and then the basic idea, if you will, is that so this is the left action, if you will, and then if you had the right action of a Lie group it's like on the manifold, then what would happen is that if you did this, you would still have something which involves the composition of P and R, but the order would be reversed. Okay, so that's how you would distinguish left versus right actions. Okay, and this has to be true for all P and Q in the group and all points Y in the manifold. Okay, so all right, so those are sort of the two basic properties you want it to satisfy. Okay, and then so this would be a group action, and what sometimes happens is that these conditions only really hold. Particularly this condition only holds for P and Q, which are in some neighborhood of the identity element. Okay, so if this holds only for P and Q, all right, sufficiently close to the identity, right? Then we say that lambda is not a group action, but it's a local action. Okay. All right. Okay. All right. So this is really just a definition of a group action. All right. So let's just stop here for a second.